So here we have a 4 link mechanism, that is, we'll write it down as A, B, C and D. So here there are 4 link mechanism which has the magnitude of A, B, C and D. These are the magnitude of each of these links here which are connected. Okay, and respectively the angle that is made by these links is, this will take it as AB is the input link, we'll consider this as the input link, BC will be the coupler link and CD will be the output link here. The link AD is fixed over here, so just write it down here, that is AB is the input link, okay. Then CD is the output link, then BC is the coupler link and link AD is the fixed link here. Now the position of the input link is given as theta, the position of the output link will be given as phi, and displacement of this coupler link, it will be given in form of beta. Okay, now the velocity, the angular velocity of the input link, it will be given as omega A, and the angular acceleration, angular velocity is given as omega A and the angular acceleration will be given as alpha A. Now let us find the displacement analysis of each of these links here. Let us do the displacement analysis. So first and foremost, let us find out what is the displacement of this link along x-axis, along x-axis. Now if you take here, if the phi angle is more than 90 degree, then we can write the equation, all these links are in equilibrium. Okay, so since all the links are in equilibrium, we can write the equation as A cos theta plus B cos beta, that is equal to D plus C cos phi, only if the phi is more than 90 degree. So we'll consider this as equation 1 here. Okay, now we can simplify this equation and write it down as B cos beta is equal to C cos phi minus A cos theta plus B. Okay, squaring on both the sides, what we get here is A minus B plus C the whole square is A square plus B square plus C square minus 2AB minus 2AC, sorry, BC plus 2AC, right? So plus 2AC, so you can write it down as C square cos square phi plus A square cos theta square plus D square minus 2 into A in C, that is into cos theta cos phi minus 2 AD cos theta plus 2 CD cos phi. So I will take this on as equation 2. Okay, So next up we'll find out what is the displacement along y axis. So displacement displacement of these links along y axis can be written as a sine theta plus b sine beta is equal to c sine phi. Okay, this can be simplified as b sine beta is equal to c sine phi minus a sine theta. So squaring both the sides will get as so yeah, this equation will take it as equation 3. Okay, and this equation squaring on both the sides will get a square minus b square will be a square plus b square minus 2ab, so it will be c square sine square phi plus a square sine square theta minus 2ac sine theta sine phi. So this will be equation 4. Now adding equation 2 and 4, what we get here is adding equation 2 and 4. So we'll write it down. The equation 2 and 4 will be a square cos square beta plus a square sin square beta is equal to, so first we'll take down this particular point, that is c square cos square phi plus c square sin square phi plus a square cos square theta plus a square sin square theta plus b square minus 2ac cos theta cos phi minus okay, so let's continue here, 2ad cos theta plus 2cd cos phi minus 2ac sin theta sin phi. So we know that sin square plus cos square is equal to 1, so you can write down this equation as b square is equal to c square plus a square plus d square minus 2ac cos theta cos phi minus 2ad cos theta plus 2cd cos phi, sorry, we got this, yeah, cos phi minus 2ac sin theta sin phi. Okay, now let us consider this particular equation over here, that is, we'll take it as a square minus b square plus c square plus d square, take this as, that is equal to 2k. We'll take this thing as a square minus b square plus c square plus c square plus d square is equal to 2k. Okay, we'll substitute this in the equation 5. This is the equation 5. We'll substitute this in this equation. So what we get here is to take this positive side here, that is 2 cd cos phi minus 2ac cos theta cos phi minus 2 ad cos theta minus 2ac sin theta sin phi plus 2k is equal to 0. So we can simplify and write this equation as cd cos phi minus ac cos theta cos phi minus ad cos theta minus ac sin theta sin phi plus k is equal to 0. So we'll take this as equation 6. Okay, now from trigonometric identities, we can write down sin phi from trigonometric sin phi can be written as 2 tan phi by 2 divided by 1 plus tan square phi by 2, and similarly cos phi is equal to 1 minus tan square phi by 2 divided by 1 plus tan square phi by 2. So this, substituting this here, can be written, it will be written as cd into cos theta is 1 minus tan square phi by 2 divided by 1 plus tan square phi by 2 minus ac cos theta into cos phi, again it is 1 minus tan square phi by 2 divided by 1 plus tan square phi by 2 minus ac sin theta, write it down, tan phi is 2 tan phi by 2 divided by 1 plus tan square phi by 2 minus ad cos theta plus k is equal to 0. Okay, now to simplify this particular equation, I'll just multiply this equation, this complete equation, by 1 plus tan square phi by 2. So if we multiply this equation, so it will get cancelled, and here also will get cancelled, here will get into multiplied by this. So we can write down this whole equation as cd into 1 minus tan square phi by 2 minus ac cos theta into 1 minus tan square phi by 2 minus AC sin theta to 2 tan phi by 2 minus AD cos theta into 1 plus tan square phi by 2 plus k into 1 plus tan square phi by 2. So to simplify this equation and write it down, we'll write it down as that is equal to 0. Okay, so it can be written as CD minus CD tan square phi by 2 minus AC cos theta plus AC cos theta tan square phi by 2 minus 2 AC sin theta tan phi by 2 minus AD cos theta, this is minus of minus again, minus AD cos theta tan square phi by 2 plus k plus k into tan square phi by 2, so that is equal to 0. So let us all get this tan square as one term and tan another one. We'll take common between all these things, so you can write it down, this whole thing as, first and foremost we'll write down this word, that is k tan square phi by 2 minus CD tan square phi by 2 plus AC cos theta tan square phi by 2 minus AD cos theta tan square phi by 2 I think the terms are done, and then minus 2AC sin theta tan phi by 2, and then we have all the other terms, that is plus k plus CD minus AC cos theta. Okay, so that is equal to 0. So we can simplify this and write it down as k minus a into b minus c d minus c cos theta minus CD tan square phi by 2 plus minus 2AC sin theta tan phi by 2 plus, this will write down here, k minus a into b plus c cos theta. I missed out this thing here, that is minus AD cos theta, this equation, okay, cos theta plus CD is equal to 0. So this is or this can be written down as, we'll consider this as A, consider this as B, and this one as C. So we can write down in a simpler formula. Similar form is A tan square phi by 2 plus B tan phi by 2 plus C is equal to 0. So here A is equal to K minus A into D minus C into cos theta minus CD, and then B is equal to minus 2AC sin theta, and C is equal to K minus A into D plus C cos theta plus CD. So the equation is quadratic in tan phi by 2. Its roots will be, written as tan phi by 2 is equal to minus B plus or minus root of B square minus 4AC divided by 2A. So the phi angle, that is the position of the output link, phi is equal to 2 tan inverse of B plus or minus root of B square minus 4AC divided by 2A. So the position of output link, that is phi, can be calculated if the magnitude of the links, that is A, B and C, and the position of the input link are known. Next, let us find out the position of the coupler link with an angle beta. To find out this, we have to consider the first equation that we had considered, displacement along x-axis, equation 1, and equation 3, that is displacement along y-axis here. So rearranging this, it can be written as the coupler link position at the angle beta be written as C cos phi is equal to A cos theta plus B cos beta minus D, and this we can take down this equation as equation number 8. The phi equation, we have to consider that equation as equation number 7. Okay, so this will consider as equation number 8, and C sin phi is equal to A sin theta plus B sin beta. So this will take it as equation number 9. Now squaring and adding these two equations, adding equation 8 and 9, what we get here is C square cos phi plus C square sin phi is equal to, again this formula, that will be A square cos square theta plus b square cos beta square plus d square plus 2 into ab cos theta cos beta minus 2 bd cos beta minus 2 ad cos theta plus a square sin theta plus sin theta square plus b square sin square beta plus 2ab sin theta sin beta. So this equation can be written as simplified and can be written as c square is equal to a square plus b square plus d square plus 2ab cos theta cos beta minus 2bd cos beta minus 2ad cos theta. So this is already written over here, sin square plus cos here, sin square yeah, this thing is done. So plus 2ab sin theta into sin beta. Okay, so right now let us take this equation, that is a square plus b square minus c square plus d square. We'll take this as 2k dash. Okay, so 2k dash here. So after doing this, what happens here is substituting this in this particular equation. So simplify and write down this equation as plus we'll take 2ab cos theta cos beta minus 2bd cos beta minus 2ad cos theta plus 2ab sin theta into sin beta plus 2k dash is equal to 0. So it can be written as this thing, rearranging this particular equation here and there. So you can write down this particular equation as ab cos theta cos beta minus bd cos beta minus ad cos theta plus 2ab sin, sorry, not 2 gets cancelled, sin theta sin beta plus k dash, that is equal to 0 here. Okay, so we'll take this as equation 10 here. So this particular equation is basically identical to the equation number 6 here. So the equation number 6 is, so you can see here that it is identical to equation number 6 here. If you rearrange this thing, then for trigonometric identities we can write it down as sin beta is equal to 2 tan beta by 2 divided by 1 plus tan square beta by 2, and cos beta is equal to 1 minus tan square beta by 2 divided by 1 plus tan square beta by 2. So substituting this in the equation number 10, what we get here is the solution will be similar. So after simplification, what we can write down this equation as k dash minus a into d plus b into cos theta plus bd into tan square beta by 2 plus 2ab sin theta to tan beta by 2 plus k dash minus a into d minus b cos theta minus bd is equal to 0. Okay, so again here we'll take this as d, we'll take this as e, and this one as f. So the solution from this particular thing we can write it down as d is equal to k dash minus a into d plus b to cos theta plus bd, then e is equal to 2ab sin theta, and f is equal to k dash minus a into d minus b to cos theta minus bd. Okay, so from this equation what we can write down is that the position of the coupling rod with the relationship of with the output link, it can be written as beta is equal to 2 tan inverse of minus e plus or minus root of e square minus 4df divided by 2d. So this is the equation 11. So this is basically the position of the coupler link that is beta with respect to the position of the input link here. Okay, so this sums up the displacement analysis of the coupler as well as the output link here.